All right, now let's work on and learn about two theorems, very important theorems in the world of polynomials. And one is called Remainder Theorem, the other one is called the Factor Theorem. So first, the Remainder Theorem. But before we actually go ahead and I just give you the theorem, I want to walk you through that. Let's actually come up with the remainder of this situation where this polynomial f of x is divided by this divisor x minus 3. Now, I said use any method you like. Doesn't matter what method you're going to use. You're going to use a synthetic division, great. You want to use the long division, that's great. I'm going to choose the long division. Just it seems that that's more problematic for a lot of students, but you can use synthetic division as well. All right, now let's go ahead and do that. I'm just going to do this right now. Just pause the video and you try that. Remember, I have added the 0x squared term for the dividend so that I know the placement, okay, so that I don't forget the x squared term. Okay, so when you go through the synthetic division systematically, that's what you will get. Okay, and I've tried to map it so that you can follow. So x squared is on top first. You're going to start with that, and then after the x squared term you're going to go with minus 3x, and you know, systematically minus 3 times minus 3, sorry, plus 3 times minus 3 is minus 9x, and then systematically bring this 6 down, the last piece. Remember, there's a subtraction in here, 5x plus 6, that's what you're going to start with. You want to get 5x out of the x. That is the kind of the green, or actually I think it's a blue, but I'm colorblind, line in here, so it's showing you what's happening. So you have to multiply 5 by x and then 5 by minus 3. You're going to get a remainder of positive 21. That's the remainder. Okay? All right. Now, what I need you to do, I need you to pay attention to what happens when we actually, this is our f of x, okay? This is our f of x. And if f of x is that, if I go, what is f of 3, can we find out the value of function when x is 3? Now, why did I get 3 in here? Because this x right there, x minus 3, to make it 0, 3 minus 3 will make it 0. So I am going to choose x equal to 3 to plug it in there. Let's see what happens and do the math. So that means 3 cubed minus 4 times 3 plus 6. What do we get? That is 27 minus 12 plus 6. What is that? That is 15 plus 6. That's 21. Here it is. Here it is. You see what is happening? So we could go through the long division to get the remainder, or we can use this pattern that if we have a x minus a, or x minus 3 in this case, for whatever makes that divisor equal to 0 for the value of x, we take that value, plug it into the original polynomial function, and then do the math. We're going to get the remainder immediately, and we don't need to go through the long division. Okay, so that's what we're gonna do. Now that we know that, let's write up the remainder theorem. Okay, so here's the remainder theorem. When a polynomial p of x is divided by a binomial of the form x minus a, so that's your x minus a right there, and that's the polynomial p of x that we have, then the remainder will be p of a. Okay, so it's very important to understand that piece of it. So remember, you're taking the a, so that not the negative a, just the a. So let's go through an example. Instead of going through the long division or synthetic division to get that, which takes longer, we can use the remainder theorem immediately. So let's go ahead. So let's find out. So first of all, what is a in here? Okay, so remember, you want to have the value, a is the value of x that makes the divisor equal to 0. So in this case, a is minus 2. Okay, so remember that. So the value of x that makes the divisor equal to 0, that is your a. All right, so now what is f of minus 2? Your input is minus 2. Plug it in there. So negative 2 let me start with the original negative 2, which is the leading coefficient, and now negative 2 cubed, and then plus negative 2 squared, and then plus 2. Let's do the math. So negative 2, that gives us negative 8, plus 4 plus 2. All right, and now positive 16 plus 4 plus 2, and that's 22. That is the remainder. If you go ahead and do the long division, you should get the same answer. And you will. All right, a couple of other things I want to point out. One is that remember that you're dividing, your divisor must be a binomial, and the form of the binomial must be x minus a. It can't be any other form because it won't work if that's the case, okay? That's the limitation of the remainder theorem. So factor theorem says, if you remember, that if you have a polynomial p of x and divided by a binomial of the form x minus a, then if you use the remainder theorem, so plug that a into that polynomial and you get equal to 0, that means the remainder is 0, then you can say that x minus a, that binomial, that divisor, is a factor. All right, so here is an example. We have is x squared plus 5x plus 6. I actually use this example purposely so that you see it. Let's suppose that that is divided by x plus 2. And some of you guys already know that you can factor that quickly, and it is one of the factors, but let's use the remainder theorem. So remember, a in here is minus 2. So what is p of minus 2? So minus 2 squared plus 5 times minus 2 plus 6. And when you do the math, that will give us 4 and 6, 10, minus 10, so that will give us 0. Yes, excellent. So the remainder is 0, and that means yes, it is. X plus 2 is a factor, and we know that because we can factor the p of x. This is just the trinomial that is factorable fully, and these are the factors of that p of x. Sure, x plus 2 is a factor. So that is the factor theorem. Okay, that simply is the factor theorem, and you can apply it every time. As long as you get the remainder of 0, that divisor is a factor. If it's not 0, then that is not a factor. Okay, let's look at another example here. And in this case, we want to check if x plus 2 is a factor of this polynomial right there. Okay, and again, let's go through that. Remember, a in this case is negative 2. So what is f of negative 2? If that is equal to 0, then x plus 2 is a factor. If it's not, then it's not. So let's go through the algebra and get that done, and then double check. Okay, when you plug the minus 2 into the polynomial function f of x, you're gonna go through that, and you notice that for the most part that's what you will have. And then you do the math properly, make sure you follow the algebra, and then you get f of minus 2 equal to 0, and therefore x plus 2 is a factor of the polynomial function. Great.